So recently I've learned a few things about replication in database, and I thought I'd go ahead and create a video. You could find this very helpful as well. So database replication is the process of creating multiple copies of a database across different servers. So if I have a database, I'd go ahead and create another copy of the same database. So the same data is going to be in both the database. Why might we need to replicate databases? Well, it could be because of various reasons. It could be due to the need for high availability, or maybe for disaster recovery, for scaling, or maybe balancing the loads in amongst databases. Now, in database replication, we have all these database replication. Now, each of these database servers are called replicas. Now, let's first start with leader-based replication. So there is a leader and there are followers. So let's say we have single leader and we have multiple followers. So each of the writes are going to go through the leader. So essentially I'm going to go ahead and write something in the leader database. Then those writes are going to be replicated amongst the followers. So this is how it is going to essentially work. So we have multiple replicas. Now one of the replicas is going to be assigned the role of leader. Now each write request has to go through the leader. Now when a user wants to write something, the request first goes to the leader. The leader first writes the data in its local storage. Now whenever the leader writes something, it sends out the replication log to the follower replicas. Each follower then picks up the replication log and then updates their local storage. Now we have the data in all of the replicas. So next time, let's say if we have a user who wants to read the data, it can fetch the data from the follower replicas. And I'm not really sure if I mentioned it already. So the leader replica is also known as master and the follower is also known as slave. So we can already see that we are able to distribute the load. Now we need to consider a few things when it comes to synchronization. So let's say the actor requested a write. The leader got the request. It writes the data in its local storage. In the meantime, it also sends out a write request to follower 1 and the user is waiting. So once the follower has finished writing to its local storage, it sends out the request back to leader. Once the leader receives the confirmation from follower 1, it then goes ahead and sends the confirmation back to the client. So in the meantime, the user had to wait for this long. So the replication process from leader 1 to follower 1 is synchronous because the leader had to wait until the write was done on follower 1 before it could send out a OK response back to the user. Now another type of synchronization process is asynchronous. So essentially when the leader receives a write request, it is also going to send out a write request to follower 2. And in the meantime, follower 2 is going to go ahead and try to write the data in its local storage, and eventually it is going to send a OK response back to the leader. So this type of replication process is asynchronous. So essentially the leader had to wait for this long for the follower to finally write the data in its local storage. The upside to having synchronous replication on follower 1 is that the most up-to-date data is available on follower 1. In case the leader goes down, we still have the data. However, the downside is that if for some reason follower 1 cannot process the write, leader has to block all writes because follower 1 cannot process the write. In that case, the leader has to wait until follower 1 comes back again. And for that reason, it is not practical for all of the followers to be synchronous. If all of the followers were synchronous, in that case, if any follower node went down, then the leader would block all of the writes. Usually, therefore, one node is made synchronous and all the other nodes is made asynchronous. If the synchronous node starts failing, then one of the other asynchronous node is made synchronous. This configuration is also called semi-synchronous, and in some configuration it is possible that all of the nodes are made asynchronous. The downside to this configuration is that, let's say the user requested a write, the leader wrote the data in its local storage and confirmed the write straight away, and let's say after writing the data in the local storage, the leader somehow failed. The leader somehow crashed. It wasn't able to forward the write request to the followers, and if the data cannot be recovered from the leader, even if the leader has confirmed the write to the user, the data is lost forever. Now the upside to making all of the followers asynchronous is that it doesn't matter if all of the followers fail all at once. So user is going to go ahead and request a write. Leader is going to go ahead, write it, process the write, and confirm the write right away. And then it's going to go ahead and request write on all of the asynchronous followers. So even if they fail, it doesn't really matter. The data has already been persisted on leader 1, and the response and the confirmation is sent back to the user. So if all of the followers are asynchronous, it means that the leader is going to always accept writes no matter what. But yeah, if the leader itself is down, it cannot process any writes.